Hi boys and girls, welcome back to the 3-4 Science Club. I am so glad to see you, well, not see you, to have you back again for class. In fact, I actually really do miss seeing you, and I can't wait until we finally have class again together. So that will be sometime in April is what I'm hearing. So I'm looking forward to that day, as I'm sure you guys are too. We're gonna start with our vocabulary words. We have 2 vocabulary words. I'm gonna just hold it up for 10 seconds on my end, but you feel free to go ahead and pause the program so that you can write your vocabulary words in the back of your notebook. Okay, let's go ahead and talk about these words. We have 2 new words that we're gonna talk about today. The first one is renewable. And renewable is a resource that can be made new again. And non-renewable is a resource that cannot be made new again very quickly. So in these definitions, in these words, we actually see the definition. So I'm gonna kind of break these words down so that you can kind of see that these words give away their definitions. Right here we have the word re. Re means again. This is kind of an awkward way to write. Okay, it means again. Re means to do something again. So if you rewrite something, you're writing it again. New means, well, it just means new. And that's our root word right there. And able means to do something, that you can do something. You're able to do something. Okay, so in this word, we see the definition. It can be new again. Do you guys see that? Isn't that cool? Okay, so non-renewable, again, we have the word renewable right here. Re means again. New means new. And able means you can do something. You're able to do something. But non in front of it means not. Or you can't. So we have cannot be new again. Isn't that cool? That in the word is the definition, if you can just break it down. So when we talk about a resource that can be made new again, that's something that you can have if something happens to it or you use it, it can come back again pretty quickly. But non-renewable is a resource that once you use it, you're not going to be able to have it again for a very, 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 very long time. And so really these are about time. How much time does it take before you have it again? And so renewable is pretty quickly, non-renewable is almost never or definitely not in your lifetime. And so what we're going to do is we're going to start with a sort, but before we get too much into our sorting, let's go ahead and look at our Bible verse for today. So I went ahead and sent this to your moms. And so here is our Bible verse for today. And I'm going to read through the paper. Let's see how well I can do that. Then God said, let us make man. Not very well. Okay, here we go. Then God said, let us make human beings in our image and likeness, and let them rule over the fish in the sea and the birds in the sky, over the tame animals, over all the earth, and over all the small crawling animals on the earth. Genesis 1:26. So God is talking, and he is saying, let's make man in our image, human beings in our image and likeness. Boys and girls, you are incredibly special. Every single human alive is incredibly special because they are made in God's image. They are incredibly special to God, and they should be incredibly special to all of us. And then it goes on to say, let them rule over all these different things. Can you list them? I see fish and birds and animals over all the earth. Wow, that's pretty much everything. And over all the small crawling animals on the earth. That means that everything in this earth, God wants us to rule over them. Now, how do you think you're supposed to rule over them? Are we supposed to be big, mean bosses? You creatures, do what I say. Is that what we're supposed to be like? How do you think God wants us to rule over them? I think he wants us to care for them and love them, right? And treat them with respect and dignity. And so think about your animals that you have. Think about a farm and all the creatures on there. A good farmer, a good rancher is going to be very kind to his animals and take good care of his animals. Now, that doesn't mean that we can't use animals for eating and for doing work and other things like that. But God has called us to be loving and caring towards animals, right? We're supposed to be good rulers over those things. Okay, so that's our Bible verse. And go ahead and glue it into your Bible verse page, which is somewhere in here. So I have that there. Okay. So go ahead. You have the other Bible verse here. And I still don't have glue today. So you have the one Bible verse there, and then you have your other Bible verse here. So that's what that's going to look like that. Okay, so go ahead and glue it onto your page. All right, if you need more time at any time, just feel free to pause. On our computer, we just push the space bar and it pauses, which is great. And then if we want to watch it again, we push the space bar again. It's a great thing. So next, we're going to go ahead and do a sort. This is the sort that you have, and it's got all these different things on here. So we're going to go ahead and chop these all up real quick. Okay, and I'm going to cut. And last time I noticed when I looked at the video that I stick my tongue out when I cut. I did not know that I did that until I watched the video. That was quite a revelation for me that I stick my tongue out when I cut. I wonder when else I stick my tongue out. So this time I'm going to try to keep my tongue in my mouth, okay? Okay. All right, so I'm going to go ahead and cut here. And you are going to cut yours. And if you need to pause the program because it takes you a little bit longer to cut, feel free to do that. And then we are going to sort these and glue them in our notebook. I feel like I need some special cutting music. Do, 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 do. I'm cutting, I'm cutting. Never mind, Miss Sylvie. And I wish I knew how to edit these videos, but I really don't, because I might have just edited out my little cutting song there. Okay, all right, here we go. So we have two categories, and I'm gonna get a pencil and write the categories, and I don't see a pencil near me. Never fear, I'm gonna move out of the frame, but I will be right back. I found a pen. That's pretty good. You guys use a pencil, okay? All right, so I'm gonna write on here our two vocabulary words. So one of our vocabulary words was non-renewable. And our other vocabulary word was renewable. So go ahead and write those in your notebooks. Renewable, okay. Yes, like that. Okay, so let's go ahead and do some sorting. And also, I need to make sure that I am doing this facing you so you can see. Now, two of these are just words, no pictures, just words, right? And so if you can remember the definition, then you can get this one pretty easily. So I'm gonna move all of this. Is this in the way, Mr. Cameraman? Okay, I'm gonna move stuff out of the way. Here we go. All right, so a resource that can be replaced quickly, that's our renewable resource. That's the definition of renewable. A resource that cannot be replaced quickly, that's our non, right? Non means not, our non-renewable resource, and that goes there like that. Okay, so now we have all these different pictures here, and we can sit and we can think about which one we think can go where. And I'll just kind of spread them out so you guys can see. And I want you to do right now, I want you to pause the program and I want you to sort them. I want you to take the time to think through them and sort them, and then we will talk about it together. Okay, go ahead and pause the program. Okay, welcome back. How did your sorting go? Let's see if we can sort these together. So a non-renewable resource cannot be replaced quickly. Let's look here at our different things that we have and see which non-renewable resources we might have. And then a renewable can be replaced. So I'm just gonna pick one up. Let's do it this way. I'm gonna pick one up and then we're gonna talk through it. Natural gas. Natural gas is under the earth. And it is something that was made a long, long time ago when plants and animals decayed over time. Now, if it was made a long, long time ago, once we use all this up, do you think it's going to be able to be replaced quickly within your lifetime or not? Natural gas is a non-renewable resource. So we're going to put that there with our non-renewable resources. Okay. Next, I'm going to pick wind. Okay, if we use wind for energy, like this is showing, will we be able to use it again and again and again? Will you be able to have more wind in your lifetime? Yes, wind is something that's not really going away. So that is a renewable resource. That can be replaced pretty quickly. Okay, I'm just going to grab the sun. Now, the sun. I know I've had discussion, I have students ask me questions about the sun blowing up, and that's something that some of my students are very worried about. We do not believe that will happen anytime in your lifetime or your children's or your grandchildren's. So that's not something you really need to worry about. You don't need to worry about something bad happening to the sun. But are we going to be able to use the sun again and again and again and again? Is that energy going to be able to be replaced quickly? Yes, we are going to be able to replace that. So that is a renewable resource, the sun. Okay, I'm just going to grab this one here. Oil or petroleum comes from dead plants and animals that were underneath the ground and that decayed over time a long time ago. So if that happened a long time ago, do you think that's something we can replace very quickly? No, we can't. And so that is a non-renewable resource. Okay, plants. So we have our plants here. This looks like a little, this is like a berry plant. If you can get real close on there, you can see that is a berry plant. So if I eat up these berries, will I be able to have another plant? Will I be able to have more berries? Yeah, I mean, they produce enough seeds that we can get them again pretty quickly. Usually within a year, we'll be able to grow another plant. So is that a resource that can be replaced quickly? Yes, that is. So that is a renewable resource. Okay, animals. We have a cow here. Y'all, I'm just going to tell you right now, Miss Sylvie loves steak. Miss Sylvie loves hamburgers. I like to eat cows. They are delicious. I also like milk from cows. It is delicious. Milkshakes, ice cream, all those things I very much enjoy. Now that doesn't mean that we want to mistreat cows. We want to treat them very well, but we also enjoy what comes from a cow. If we turn this cow into a lot of steaks and a lot of hamburgers, because you get a lot of steaks and hamburgers from one cow, will we be able to replace that cow pretty quickly? Yeah, within a year, a baby calf is born and grows. Maybe in 3 years. I'm not a rancher. I don't know exactly how long it takes, but I bet you could get another cow pretty quickly, definitely within your lifetime. And so is an animal a renewable or a non-renewable resource? It's a renewable resource. It's a resource that can be replaced pretty quickly. Put that right there. Okay. All right, coal. Coal, again, comes from dead plants and animals under the ground that were there and decayed a long time ago. And if that's the case, it happened a long time ago, are you going to be able to replace it in your lifetime? No. So that's a non-renewable resource. Water. Now, if you run out of water around where you're at, usually it will start to rain. Okay, eventually it'll start to rain, you'll have rain, and the water will be replaced. And it doesn't usually take very long for that to happen. Even if you have a drought, droughts don't go on forever. Within your lifetime, the water is returned. So this is a renewable resource. These fossil fuels, these are fossil fuels. So if you look here, you can see that fossil fuels is all of these things. You can see the coal, you can see the oil, and you can see the natural gas, right? So all these things are fossil fuels. And so fossil fuels are non-renewable. And last but not least is uranium. And this is a special mineral in the ground that they can use to make energy in a power plant. And it's a controversial thing because some people think it's very dangerous and some don't think it's dangerous. But uranium is a mineral found in the ground. And it's been there for a very long time, and it would take a very long time to replace. And so for that reason, this is non-renewable. So yours doesn't have to be in exactly this order, but it should look something like this. You should at least have these things on this side and these things on this side. Okay, boys and girls? So go ahead and get those glued into your notebook, and we're going to move on to our next activity. Okay, moving on to our next activity, we're going to do a little experiment. We're going to look at how they get oil out of the ground. So the oil is very deep, and they'll have these pumps, kind of like what's in this little picture. They have these pumps that create suction and pull the oil out of the ground. And sometimes it can be kind of tricky if the oil is very deep. And so they have to create all kinds of special instruments in order to be able to get that oil out. And I kind of want you to see what that might be like, how much suction they might actually have to be able to produce in order to get the oil out. So I have these 2 lab pages for you. These are our 2 lab pages here. And it's called Getting the Oil Out, and then you have some questions. So we're going to put our lab notebook away. If we try to glue this in, as you guys know, it makes it difficult for us to write on. So we're going to move those out of the way. So these are our lab pages here. Problem: how can we model how professionals remove oil from the earth? And these are our materials. We need 8 straws. So let me get my straws out. If you have your materials at home, you can follow along. So let me see, 1, 2, 3, 4, 5, 6, 7, 8. So I only need 8 straws. I'm gonna put these away. If you have the bendy straws, that's fine. We're gonna work with that. That's totally okay. And I think bendy straws are really fun. I really like bendy straws. Okay, and scissors, and tape, and a cup of dark liquid. So here's my cup. And y'all know Miss Sylvie likes her soda. It's one of my weaknesses. I have many. It's just one. You might be using chocolate milk, or maybe just some colored water, or Kool-Aid, or something else that your mom may give you. Whatever mom says, she's the boss, okay? So you just use whatever it is that mom gave you. And so it says, we're going to read all the instructions first, and then we're going to go for it, okay? So 1, cut a 1 centimeter slit at the end of each straw. Number 2, attach all of the straws together by inserting the slit end into the next straw to form one long tube. Number 3, use the tape to secure each connection. Number 4, place the cup of liquid on the floor, so maybe tile is a good idea, maybe somewhere in the kitchen, and try to suck the liquid up. Number 5, decrease the number of straws to 4, only 4 straws, and try to suck the liquid up. So let's go ahead and write our hypothesis. Now that we understand what we are doing, let's write our hypothesis. Hypothesis, and remember we do this in an if-then statement. If I do this, then this will happen. If I test both a long tube and a short tube to suck up liquid, then you go ahead and write there what you think what your hypothesis is. What do you think? Maybe you can say, then the shorter tube will work better, the longer tube will work better. I'm gonna have to suck really hard with both of them. The liquid will come all the way up, half the way up. You write what you think will happen. Go ahead and pause the program so you can do that. Okay, now let's go ahead and get started. Before we do our diagram, we can do our diagram afterwards. So let's go ahead and get started. Now it says to cut a slit 1 centimeter at the end of each straw. Only one end, okay? So we're just gonna cut, it doesn't have to be exactly a centimeter, just a little slit. And so then what happens is we're able to put it inside the other straw. That's the idea. If you can cut the slit, then you have room to be able to secure it into the straw like that. Okay, my cameraman got really close. Good job, cameraman. Okay, and so now I'm gonna cut the next one. And I'm gonna attach this one in here, like that. And I'm gonna cut the next one. All we're doing is making a really, really, really long straw. The longest straw, that's what we're making. Okay, I'm gonna push that one, I cut that one a little bit more than 1 centimeter, so I pushed it in a little bit more. The longest straw. You see my straw? And I'm not even done yet. Can you believe it? All right. I bet your straws are very long also. This one's already cut. Okay, so my last one is going in. If you need to pause at any time so that you can do it too, feel free. And now what I'm gonna do is I'm gonna take, boys and girls, I get my tape at the dollar store. I think Miss Sylvie should probably buy nicer tape. We go through so much of it in class that sometimes I just go, oh, is Mr. Sylvie, my cameraman, nodding yes? Mr. Sylvie sometimes finds our tape. And this is what it looks like. It's, you know, it's cracked and it's falling apart and he is not very happy about it. But I tell him, you know, I use it for class and I need a lot of it. So it's okay. So maybe your tape at home is nicer than my tape. Or maybe your mom uses a lot of tape too and so yours is from the dollar store. We're gonna tape each end that we connected together so that it's very, very, very secure. Each end. And maybe you have masking tape, that's okay. Maybe you have packing tape, that's okay too. Maybe you have duct tape, sure. Duct tape fixes everything, right? Oh no, see, mine fell apart. This is why it's really important that we do this, that we tape it up. Being a little stubborn. Doesn't want to go in there. Don't be scared, little straw. It'll be okay. You will see what we are doing. And last but not least, so I'm gonna go over to the floor on the other side. My cameraman is gonna follow my feet as I take my dark liquid and my super duper, ooper duper long straw. He's gonna follow me along, and we're here on the ground. So there is my dark drink. And I'm going to use my straw. Or should I stand right here? They're gonna need to get me too doing it. I'm gonna use my dark straw and I'm gonna suck as hard as I can. So do you wanna look at the straw and see how high I can get it? So you can see the dark liquid in there. So you can see, and now it's slowly going down. There's lots of air in the line, which makes it real difficult. So I'm not actually getting very much to drink. See how much is still left in the cup? I'm mostly getting air. So, oh, and then see how it goes all back down in there? See it bubbling because it's going back down? So it's really quite a bit of work. You need quite a bit of suction to be able to get it up. And you can still see some of it is stuck here in the straw. See our dark liquid is still somewhat stuck in the straw. And so when our professionals get oil out of the ground, it's actually really kind of challenging for them. So now let's say the oil is closer to the surface. So let's go ahead and try just 4 straws. So I need to take away 4. I have 8 and I want 4, I have to take away 4. 1, 2, 3, 4. And this is one long yellow one here. So I'm gonna go ahead, Mr. Sylvie, I'm gonna step out of frame for just a second. Cameraman, can you hold that for a second? I'm gonna get some scissors real quick. Okay, here we go. So I need to remove these 1, 2, 3, 4, and I'm gonna cut right here. So now I only have 4 straws, and now I'm gonna try this one. I still got quite a bit of air. I still had to work quite a bit, but you can see how much I was able to drink because see the condensation from where it was cold was all the way up to here, and I was able to drink quite a bit. Let me see if I can drink more. And then it fills back up when I stop sucking. And there is some stuck in there, but not quite as much. So you can see that having only 4 straws, I'm kind of out of breath out of drinking all of that liquid. Having only 4 straws is a lot easier to drink from than having 8 straws. So the shorter your straw, the easier it is to drink. And so for our oil professionals who get the oil out of the ground, having a shorter section is much easier than having a longer section, a longer tube. So I'm gonna take that out, and I'm gonna set my cup up here, and I'm gonna come back around. So boys and girls, at this time, you can go ahead and draw your diagram of what you saw. So I would think that you would have something like a cup, some straws, and then your dark liquid, and label it also, dark liquid, cup, straws. So some kind of drawing here that shows what your lab setup was. Okay, and we now have these questions to answer here. So go ahead and pause the program and take some time to answer questions 1, 2, 3, 4, and 5. Okay, let's talk about your answers. Number 1, was your hypothesis correct? So that would be yes or no. And then it says why or why not. So then I would see something about you elaborating why your hypothesis was not correct. How does the length of tubing affect the amount of suction needed? Something along the lines, and it's okay if it's not exactly like this, the longer the tubing, the more suction, or the less tubing, the less suction. Number 3, how do you think this models how oil is taken out of the earth? And so something along the lines like there is tubes that are used to extract the oil from the ground, and they use suction to pull the oil through the tubing. Something along those lines. Number 4, how does it not model how oil is taken out of the earth? Well, I drank soda, and that it's oil, so it's definitely different. And then the oil comes out of the rock, and where is it in the rock? We could see where the soda was. So there's a lot of things that you can put about how this model is not necessarily the perfect example of how it happens in the real world, right? So there's all kinds of things you can put for that one. Number 5, if you were going to do this experiment again, what would you do differently? What else would you want to test? Now, some of you might be saying, well, I would want to do chocolate milk. Well, that's not really what this is asking. This is asking maybe how to understand more about how oil comes out of the earth. And I'm sure you have all kinds of great ideas about how we could do something different to make this a better model of how oil comes out of the earth. Okay, boys and girls, so for this now, I want you to go ahead and glue this into your lab notebook. And so you should have 2 pages, maybe something like this. And if you have something on this page already, you can put this one here and then this one here. But go ahead and make sure to glue these into your notebook so that you have a record of your hard work for this year, right? We want to make sure we always have a good record of our science. And what is neat is to go back and look at it later, you know, in a few years. You can go back and remember the things that you learned in your 3rd and 4th grade science club. Okay, so we have those glued in. Let's move on to our next activity. Now for this one, we have a fun game. And I sent this to your mom. And so maybe you can play this with a brother or a sister. And you can play, or your parents. I know right now is a great time for different board games. And now a dice, you might need to get a dice from another game that you have. Monopoly usually has a dice, something like that. So you might need to get a dice from another game that you have. So you need a dice. And then I cut out these little game pieces. And there's 4 different game pieces. You might have to remember which one is yours. Maybe you need to put an initial on it. If you're just playing with a brother and sister, you can each have one. Now the orange is petroleum, okay? It's oil. And the blue one is natural gas. And so what you're gonna do is you're gonna roll the dice, and say I'm natural gas. You know, I started at start. I'm gonna go 1, 2, 3, 4, 5. And I'm gonna learn that environmental engineers ensure that the well sites meet federal, state, and local regulations. They also plan reclamation projects when extraction is complete. So over here on this page that you also have, it says, what careers did you land on? Well, this is a career, an environmental engineer. And so you would write, if this was me, I would write environmental engineer. Okay, and then you roll the dice again. 4, 1, 2, 3, 4. Roughnecks. Okay, now I'm gonna write roughnecks on there. Roughnecks guide the tower ends of pipe. The lower ends of pipe to well openings and connect pipe joints and drill bits. Oh, okay. So they actually do the work with the piping, like kind of how we made the straws, but they do it with actual pipes. Okay, I'm gonna roll the dice again. 1, 2, 3, 4, 5. Now, if I was playing someone else, they would get a turn. Chemical engineer, and oh, my stepsister's husband is a chemical engineer. That's what he does. And so let me see what he does. He designs chemical plant equipment and develop processes for manufacturing chemicals and products like gasoline, detergents, and plastics. Oh, interesting. And I would write chemical engineer. And then I would roll the dice again. Oh, I got a 5. I feel like I got a 5 every single time. 1, 2, 3, 4. So then I stop here. And I'm gonna wait for my partner. You know, we've been taking turns. And then I'm going to roll the dice. 6. Since I'm natural gas, I'm gonna land over here at 6. And it says, you are sent to a house and used for space and water heating. Oh, so that's what I did. And so answer, it says, what resource were you? And I would put natural gas. How were you used? And I would say I was used for space and water heating. So these are the questions for you to answer as you play this game. And number 4 has a big hint. Make sure you're paying attention to that hint. So it's kind of a fun way to learn about a bunch of different jobs in the oil and gas industry.